scientific evidence is stronger than ever. Human influence on the climate system is clear. Recent anthropogenic emissions of greenhouse gases are the highest levels in history. Climate change has caused widespread and profound impacts on human and natural systems. We have to act quickly and decisively if we want to avoid increasingly destructive outcomes. But we do have the means to limit climate change and build a better future.
The fifth assessment report is by far the most comprehensive, most up-to-date assessment of climate change that has been carried out so far. This is what makes this assessment is so unique. The amount of effort that has gone into it, the scope of the literature that has been assessed is by far beyond what we have been able to do so far.
In 2013 and 2014, each of the IPCC's 3 working groups released a detailed report on different aspects of climate change, totaling nearly 5,000 pages and assessing over 30,000 scientific papers.
The synthesis report is a combination and integration of 3 working group reports. It is written in a manner that policymakers can understand the science. It provides a roadmap on the basis of which policymakers can take action and deal with the challenge of climate change.
Warming of the climate system is unequivocal. Since the 1950s, many of the observed changes are unprecedented over decades to millennia. The atmosphere and ocean are warmer, the amounts of snow and ice have diminished, and sea level has risen.
Well, I think in AR5 we've done a much better job of expressing exactly how much different contributions, particular greenhouse gases, have contributed to global warming in the past and how they will contribute in the future. We're able to demonstrate that the CO2 concentration in the atmosphere has increased by 40% since pre-industrial times, mostly as a result of human activities, and that the levels of carbon dioxide in the atmosphere are higher than they've been for the last 800,000 years in Earth history.
Despite measures to limit climate change, from 2000 to 2010, emissions were the highest in history. The contribution of population growth between 2000 and 2010 was roughly the same as that of the previous 3 decades, while the contribution of economic growth rose sharply. The effects of global warming are most evident in some of the coldest places on the planet. Ice sheets and glaciers worldwide are losing mass. Permafrost is thawing, and the snow and sea ice cover in the Arctic is decreasing. The observed changes in the cryosphere have serious implications. With less snow and ice, more of the sun's energy is absorbed by the ocean and land surface.
The warming of the ocean will continue even if we stop the atmospheric CO2 concentrations to increase, because the time scale of the ocean circulation, which connects the surface to the deep ocean, is very large in the sort of hundreds and thousands of years.
A warmer atmosphere is also contributing to higher sea levels.
Over the 20th century as a whole, the dominant contributions are ocean thermal expansion and the contribution from the loss of mass from glaciers. Sea level has risen by about 19 centimetres by 1900 to 2010, and it's continuing to rise. We will have to adapt to sea level rise.
Our understanding of the climate system relies on combining observations and studies from many different scientific disciplines. With the help of supercomputers, this knowledge can provide us with climate projections of the future.
Climate models play an absolutely crucial role in this assessment report. They are the only tools that allow us to say something quantitative about the future.
We have looked at all the evidences that tell us how the climate has changed in the past and presently, took that evidence to ask ourselves how we understand the climate system, what the causes of these changes are, and then take that knowledge and climate model simulation to ask ourselves what possible futures are there.
Substantial and wide-ranging impacts of climate change have occurred across the world. Climate change is already affecting ecosystems, human health, fresh water resources, and agriculture.
The main message from all of these observed impacts is that many features of ecosystems and the economy are very sensitive to changes in climate. And when we look forward to the possibility of changes in climate that are much larger than the ones we've already seen, the risk of much greater impacts is also very clear.
The impacts of extreme climate events tell us a lot about current vulnerability and exposure of ecosystems and societies.
What we're observing is a significant adaptation deficit in both developing and developed countries. Society at large is actually more vulnerable and more exposed to climatic extremes, even in the current climate, than one might expect. And that tells us something about the challenge of moving forward into a changing climate where we have yet to catch up with where we're at now.
It's important to consider regional and local settings to understand the risks associated with climate change.
Living at the margin of society and being highly exposed, like living in a floodplain or being homeless, makes people vulnerable to climate change, not a flood or a drought or heat stress per se. So it's about these inequalities that exist in every society, both in the north and the south, that make people vulnerable. And often they're associated to gender, to age, well-being, health, class, race, ethnicity, and whether or not people have access to resources and a stake in decision-making processes.
The risks for people, societies, economies, and the environment increase with further warming. Mitigation can reduce these risks.
I think one of the key messages from Working Group 2 is that adaptation and mitigation are complementary activities.
One of the real challenges we face is establishing the understanding that the benefits of adaptation and the benefits of mitigation play out on different timescales.
Sure.
Investments in mitigation in the short term really lead to an era of climate options in the long term.
We know there will be cost in taking action, but taking no action will cost us a lot more. The impact of climate change will become progressively severe and far beyond the scope of ability to adapt to them. The action has to be taken now.
Adaptation to climate change is starting to occur. Flood barriers and improved drainage reduce the risks from flooding in large cities. Farmers are managing their lands differently, for example, changing planting times or using different varieties. New climate-smart buildings make cities more resilient. Local farmers are teaming up to replant natural forests, decreasing the risk of flooding during heavy rainfall and fighting deforestation. International cooperation is a key factor to limit future climate change.
It costs each individual nothing to dump her gases, and it costs nations very little to dump their own gases into the atmosphere, but the harm done by that is borne by people all over the world. That means the atmosphere gets overused as a dump for greenhouse gas, and that is the tragedy of the common. We have to find a way of reducing that.
The report shows very clearly that we need a fundamental departure from the business as usual scenario. We have to implement a broad portfolio of technologies ranging from renewables to nuclear power, energy efficiency improvements, and the implementation of carbon capture and storage. All sectors have to contribute to mitigation. Technologies and institutions are the missing component in climate policy. Some of the technologies are already competitive, but for ambitious climate policy, we need a fundamental upscaling of these technologies. Institutions are not in place. We need international cooperation at an unprecedented scale if we want to achieve a 2-degree target. And here we need really smart solutions to facilitate and to enable international cooperation.
To reach ambitious mitigation targets, we need cross-sectoral mitigation. An example can be found in the agriculture, forest and land use sector.
There are 2 sets of major mitigation routes. One of them is afforestation. So you plant wood, for instance, trees, and the tree grows. Up to a certain point, it picks up a lot of carbon. That's one option. But the other measure would be to take that tree and then convert it to energy, but capture all that carbon dioxide and sink it into a geologic storage. So that's called BECS, Bioenergy and Carbon Capture and Storage, that would provide negative emissions.
Large-scale mitigation measures can also have benefits beyond curbing negative climate change impacts.
Let me take the case of Africa, where the energy system is not yet in place. There is 2 options. You can go for fossil or you can go for clean energy aspect.
Electrifying the African continent with clean, renewable energy would have co-benefits. A reduction in the use of wood and other biomass for cooking and heating could ease the pressure on local resources and also have health improvements through better indoor air quality. But there are challenges.
It will require new type of investment, a massive investment in the beginning for the initial cost of any of those different options. Unless we have those possibilities, the financial possibilities, it might be difficult to do it.
The IPCC 5th Assessment Report is the result of an unprecedented collective scientific effort. Rigorous measures are taken to ensure that the assessments are objective and reliable.
IPCC reports are prepared by teams of renowned experts from all regions of the world and according to very strict procedures. While we focus our assessments on climate change, the area of expertise has expanded considerably, ranging from atmospheric science, natural science, but also including engineers, social science, and also philosophers. As the name already says, governments are the members of the IPCC, and governments ask experts to do reports. They scope the reports together with experts, and at the end of the assessment process, adopt and approve reports. It signifies that governments agree with the scientific findings.
Human influence on the climate system is clear. If we want to limit climate change, we need substantial and sustained reductions in greenhouse gas emissions.
The longer we wait, the harder it will be to deal with climate change.
The impacts of climate changes that have already occurred are widespread and consequential.
It really comes down to a matter of choice. We either continue on our current path and face possibly the catastrophic consequences of climate change, or we listen to the voice of science and act accordingly. The choice is ours.